The quantum revolution is knocking. Are you ready? Have you ever thought about problems so big, so incredibly complex, that even our fastest supercomputers today would just throw up their digital hands in defeat? I'm talking about challenges that would take them billions of years to solve. Well, hold on to your lab coats, because a new kind of computing is here and it's ready to tackle those colossal tasks. It's called quantum computing, and it's not just a little bit faster. Oh no, it's a whole new way of thinking about calculations. Imagine trying to find your way through an enormous maze. A regular computer tries one path, then another, then another. A quantum computer, though, it's like it can explore all the paths at the same time. How cool is that? Get ready, because things are about to get quantum. Alright, let's talk about your computer. It works using something called bits. Think of a simple light switch. It can be either on or it can be off. When it's on, we can call that a 1. When it's off, we can call that a 0. That's a bit. It's a fundamental piece of information in all classical computers. This binary system, just ones and zeros, is the backbone of the digital world we live in. But some problems are just too complicated for a system that only knows on or off. Now get ready for the quantum superstar, the qubit. Imagine that light switch again. Instead of just on or off, what if it was a dimmer switch? It could be fully on, fully off, or any brightness in between. Or picture a coin spinning in the air. While it's spinning, it's not quite heads and it's not quite tails. It's kind of both at the same time, right? That's what a qubit can do. This amazing both at the same time ability is a core quantum concept called superposition. We've already touched on superposition. Remember that spinning coin? A qubit can be a 0, a 1, or a blend of both, all at the very same instant. It allows quantum computers to explore many possibilities in parallel. Then, there's another spooky, super cool quantum phenomenon called entanglement. Imagine you have two of those special spinning coins, our qubits, and these two qubits are entangled. This means they are linked in a very special way, no matter how far apart they are. If you look at one qubit and it lands as a 0, you instantly know that its entangled partner, even if it's miles away, will be a 1. It's like they are communicating faster than anything we know. Albert Einstein famously called this spooky action at a distance. It's a key resource for quantum computing and quantum communication. And let's not forget interference. This is another quantum trick that computers use to their advantage. Think about ripples in a pond. If you drop two pebbles into the water, the ripples spread out. Quantum computers use interference to amplify the probability of getting the correct answer, while simultaneously canceling out the pathways leading to wrong answers. This is the heart of the quantum advantage, folks. It's a whole new paradigm for processing information. So we've talked about these amazing quantum powers, but what can these super-duper computers actually for us? One of the most exciting areas is drug discovery and development. Think about creating new medicines. It's an incredibly complex process. Quantum computers, with their ability to simulate molecules in exquisite detail thanks to superposition and entanglement, can explore many different molecular structures and interactions simultaneously. This could dramatically speed up the discovery of new life-saving drugs for diseases like cancer, Alzheimer's, or even new antibiotics to fight superbugs. And what about creating brand new materials? Imagine materials that are stronger than steel but lighter than plastic. Or materials that can conduct electricity with absolutely zero resistance, even at room temperature, true superconductors. This would revolutionize energy transmission, making our power grids incredibly efficient. Quantum computers can help us design these designer materials from the atom up. They can model how atoms and molecules interact and bond, allowing scientists to predict the properties of new materials before they are even synthesized in a lab. The potential to solve some of humanity's biggest chi. They can model how atoms and molecules interact and bond, allowing scientolenges is truly immense. Section 5, the quantum journey, where we are and the hurdles ahead. Now building these quantum marvels is no walk in the park. It's really challenging. Think about it. We are trying to control and manipulate individual atoms, electrons, or photons, the tiny particles that obey the strange rules of quantum mechanics. These quantum systems are incredibly delicate. They are super sensitive to the smallest disturbances from their environment, like tiny vibrations or stray electromagnetic fields. Keeping them in their quantum state is a huge engineering feat. The quantum bits or qubits that we have today are still quite fragile. They can easily lose their special quantum properties, their superposition and entanglement. Scientists call this problem decoherence. To combat decoherence, current quantum processors often need to be kept in heavily shielded environments, sometimes cooled down to temperatures colder than outer space, close to absolute zero. That requires some serious refrigeration technology. We are definitely still in the early days of quantum computing, but don't get discouraged. The progress in this field is happening at an astonishing pace. Section 6. Quantum Myths. Let's bust those crazy ideas. With any revolutionary new technology, especially one that sounds as futuristic as quantum computing, a lot of myths and misconceptions can pop up. You hear all sorts of things. Some of it is based on excitement, some on misunderstanding. So let's put on our myth-busting hats and clear up a few common ones about these amazing machines. Myth number 1. Quantum computers are going to make all our current classical computers obsolete. Not true. Classical computers like the one you're using now are incredibly good at what they do. They are perfect for everyday tasks like writing emails, browsing the internet, playing games, and running spreadsheets. Quantum computers are designed to be specialized tools. They excel at solving certain types of incredibly complex problems that are impossible for classical computers. Think of it this way: we have cars for everyday travel, but we also have rockets for going to space. Both are useful, but for very different purposes. Quantum computers will likely work alongside classical computers, complementing them. Myth number 2. Quantum computers will be able to solve any problem instantly, like magic. Poof! Answer! While they are incredibly powerful and can offer enormous speedups for specific algorithms, they are not magical devices that can provide instantaneous answers to everything. The quantum future isn't just a dream, it's actively being built today. Section 7. Peeking into tomorrow, the awesome future powered by quantum. So, if we gaze into our crystal ball, what does the future powered by quantum computing look like? Well, prepare to be amazed, because the potential is truly staggering. We're talking about breakthroughs that could redefine entire industries and solve some of the world's most pressing problems. Imagine a future where diseases that plague us today are easily curable or even preventable. That's one of the biggest promises of quantum computing. In the realm of medicine, the impact could be revolutionary. Quantum computers could enable the design of highly personalized medicines, tailored specifically to an individual's unique genetic makeup and disease profile. This could lead to far more effective treatments with fewer side effects. Imagine developing cures for complex diseases like Alzheimer's, Parkinson's, or many forms of cancer. By accurately simulating how drugs interact with biological systems at the molecular level, quantum computers could unlock new therapeutic pathways that are currently beyond our reach. Understanding the intricate dance of molecules within our bodies is key, and quantum computers are the perfect tool for that. The impact on technology and society will be profound and far-reaching. It truly is a new frontier of innovation. Section 8. Your computer today and the quantum dawn. So let's circle back to that burning question we started with. Is your trusty computer, the one sitting on your desk or in your lap, already obsolete because this amazing quantum revolution is underway? For all your everyday tasks, writing that school report, chatting with friends, watching awesome science videos online, the answer is a resounding no. Your classical computer is still your go-to digital companion, and it will be for a long, long time to come. It's perfectly designed for what you need it to do. However, the landscape of computation is undeniably shifting. A new, incredibly powerful form of computing is emerging from the labs and into the world. Quantum computers aren't going to replace your PC for checking your email or editing your photos. That's not their job. They are being built for something much grander, much more complex. They are being designed to tackle humanity's grand challenges, the kinds of problems that have stumped us for generations, from unraveling the mysteries of the universe to curing intractable diseases and creating a more sustainable planet. The quantum leap is happening right now, folks. It's a thrilling journey of discovery filled with immense challenges, yes, but also with even more incredible potential. So my advice to you is to stay curious. Keep learning about this amazing field, because the future is undeniably quantum, and believe me, it's going to be absolutely amazing.